My name is Mallikarjun. I am your structural analysis subject faculty. Here I am going to discuss one important concept from structural analysis subject. Okay, and there is one chapter, analysis of determinate trusses. Okay, so why I am saying this is the important topic. This chapter concepts will use in ILD chapter. How to draw ILD for trusses will use this chapter concepts only. And especially in energy principle chapter will use analysis of determinate trusses concepts. Okay, so here first I'll show the practical examples for trusses. Okay, so here I'm going to discuss analysis of determinate trusses, only trusses. Okay, right. So this is the industrial building, nothing but truss only. Okay, and here bridge truss. Okay, this is a practical example. And one more is transmission tower. So this is also a truss. Okay, students, we have three conditions to identify the frame. Is it pin jointed frame or rigid jointed frame? Okay, first condition is for pin jointed frames, all joints are pin joints. Okay, if you see here, students, right, here in this diagram, these members are connected to one white color plate. Okay, at each and every joint there is a one white color plate is there, right? Okay, and this plate is known as gusset plate. Okay, so in trusses at each and every joint, okay, and number of members connected to this plate, and this plate is known as gusset plate. Okay, just gusset plate will accommodate the members at the particular joint. Clear? This is the first condition. It means all joints are pin joints in case of pin jointed frame. Okay. Second condition, in trusses, members must be straight. All members must be straight. If you see here, each and every member must be straight or not? Yes, all members are straight only. If any one of the member is not straight, nothing but curved member, then it is not called truss. It is called rigid jointed frame only. This is the second condition. And third condition, in trusses, loads should act only at the joints. Loads will not act between the joints. It means load will not act on the member. Always in the trusses, loads will act only at the joints. Okay, not between the joints. If the load will act on the member, then it is not called truss, it is called rigid jointed frame only. So these are the three conditions to identify the given frame. Is it pin jointed frame or rigid jointed frame? What is the first condition, students? All joints are pin joints. Second condition, members must be straight. And third condition, load should act only at the joints. Clear this, everyone? Yes or no, students? Please respond. Yes. Okay. Now students, these are the practical examples for trusses, right? If you see, here all the panels has triangular shape, right? Yes or no? This is one vertical member and this is one vertical member and here there is a one diagonal member. It means this is the triangular shape, right? And this is also triangular shape and this is the triangular shape. Can anyone tell why trusses has triangular shape? Each and every panel has triangular shapes in the trusses. What is the reason? Why trusses has triangular shapes? Why trusses has triangular shape? Each and every panel has triangular shapes only. Okay, students, the perfect shape of the truss is triangle. Okay, the perfect shape of the truss is triangle. Now I'll show one animation. With this animation, you will know why trusses has triangular shape, each and every panel. Okay, right. Now look at here. Okay, now this is the truss bridge. In this truss bridge, each and every panel has triangle. Yes, this is a triangle, 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 triangle. Okay, right. Now this is a truss bridge, right? Now I'll show one vehicle will move from one end to another end. Okay, now see this. Right. So two members are, okay, right. Students, due to this vehicle, this truss has deflected. Okay, then after it is regain its original position or not? Yes, it regain its original position. If it is regain its original position, then only it is called internally stable structure, right? Yes, it is called internally stable. It regain its original position. Okay, I'll show this one more time. Right, look at here. Yes, regain its original position. Now it is safe only, it is stable. Okay, then students, this is after marriage. Two couples are there, this is after marriage. Okay, now I'll show one more truss. Now here there is a triangle shape is missing, right? So no, in this panel there is a no triangular shape. I told the perfect shape of the truss is triangular shape na. Now if there is a missing of triangular shape, then what is the problem? Okay, now two couples are moving before marriage. Now look at here, with lots of love. Then what happened? Unstable structure. Okay, I'll show one more time. Yes, this is unstable structure. Okay, so this is the problem. So I told the perfect shape of the truss is triangular shape. Each and every panel has triangle, then it is internally stable structure. Okay, so don't go out before marriage. Better go out after marriage, then you will be safe. No breakup. Okay, right. Now, students, there is one assumption, right? You know, truss members are subjected to only axial forces. It may be axial compressive force or axial tensile force. Okay, it's subjected to shear force and bending moment also, but compared to axial force, shear force and bending moments are negligible and will neglect in the analysis part. Okay, so if I ask you to analyze the trusses, means we have to find only axial forces. It may be axial compressive force or axial tensile force. No shear, no moment. It is negligible only. Okay, so now we are going to start analysis of trusses. Okay, we have two methods. Okay, one is method of joint, another one is method of section. Most of students will feel difficult method of section. Here I am going to discuss method of section only, because method of joint is very easy. Okay, right. Students, in method of section, we have equilibrium equation of a joint, equilibrium equation of a structure. So before starting analysis, I want to tell you how many number of equilibrium equations. Students, for pin jointed plane frame, for pin jointed plane frame, number of equilibrium equations are always 3. Okay, for pin jointed plane frame, how many number of equilibrium equations? It is 3. So what are the 3 equilibrium equations, students? So I am giving notation. S is represent number of equilibrium equations. So here sigma H equals to 0, sigma V equals to 0 and sigma M equals to 0. Okay, these are the 3 equilibrium equations. Now using these 3 equilibrium equations, we are going to analyze the trusses. Okay, right. So method of section. Okay, for example, I'll consider one diagram. So there is a load acting W. This is point A, B, C, D, E, F. Okay. For example, length is L, height also L. Okay. Now we'll analyze this truss by using method of section. Okay. Right, students. First, we'll find the support reactions. Okay. At the hinged support, number of reactions are 2, right? Okay. What are the 2 reactions? Horizontal reaction and vertical reaction. And at the roller support, only one vertical reaction. It is VB. Right. First, we have to find the support reactions. Right. Students, this is symmetrical truss, right? Load is acting exactly at the center only. If the load acts at the center, then this total load taken by these 2 supports, right? It means this total load share these 2 supports equally. It means W by 2, W by 2. Okay, W by 2, W by 2 directly, because load is acting at the center. Next, we have to find horizontal reaction at support A. To find the horizontal reaction at A, use sigma H equals to 0. That is, right forces equals to left forces. Okay, right forces equals to left forces. Now in this diagram, what are the right forces? Only one right force is there, that is HA. Now here right force is HA equals to, what are the left forces in this diagram? There is no left forces in this diagram, then equals to 0. It means what is the horizontal reaction HA value here? It is 0. Yes, HA equals to 0. Right. So we calculated support reactions. Next, analysis means we have to find the member forces, right? What are the member forces here? Only axial forces we have to find in this, okay, for this diagram. Right. Students, can anyone tell what is the meaning of section? You might have calculated shear force at the section, bending moment at the section, right? Can anyone tell what is the meaning of section? What is the meaning of section? What is the meaning of section? Students, section means imaginary cut. Okay, section means imaginary cut. I'll tell you one example. For example, in our body, inside fluid is flowing, right? Yes, inside fluid is flowing. How to see the inside fluid? Take one blade and cut your hand. Then you can see the inside fluid, right? Yes. Okay. Then similarly, in the member, internal forces are there. Then how to know the internal forces? Cut that member. But practically, we never cut the member. We have to imagine a cut. That is the meaning of section. Okay, what is section? Section is a imaginary cut to know the internal forces, nothing but member forces. Okay, right. Now this complete topic depends upon how to cut the structure. Okay, you can cut the structure horizontally cut to, vertically cut to, U cut to, V cut to, any zigzag shape. But two conditions must satisfy. Okay, what are the two conditions? Okay, I'll tell you. Right, students, generally, if it is objective question, examiner will ask to find the force only in single member or only in few members, not in all the members. Finding forces in all the members, it is a conventional question. Okay, but here I want to find the force only in few members. For example, okay, I want to find the force in member DC. Okay, I want to find the force in member DC or CD, whatever it is, both are same only. You can write CD or DC, both are same members. Right. Now students, I want to find the force in member CD, right? Okay, then I told how to cut the structure, it depend upon two conditions. First condition is, in which member we want to find the force? CD, right? Then cut the member CD compulsory. It means pass a section through selected member. Which one is selected member? In which member we want to find the force, that member is selected member. Okay, so here I want to find the force in member CD, right? Now section should pass through selected member compulsory. Okay, now this is the first condition. Yes, now students, now section passing through member CD or not. Nothing but we are cutting the member CD. Now this is the first condition. Then second condition, section should divide the entire structure into two separate parts. Okay, if I cut only one member, this section, is it dividing entire structure into two separate parts? No. Okay, there is a connection here and there is a connection here. Then if I cut the structure like this, okay, if I cut the structure like this, cutting the structure means it is a section only, students. I told section is a imaginary cut. Okay, so if I pass a section like this, now two conditions are satisfying or not, check it. Okay, first condition, section is passing through selected member or not? Yes, it is passing through member CD. Second condition, this section dividing entire structure into two separate parts or not? Yes, left part, right part completely separated. Okay, so how to cut the structure, it depends upon these two conditions. First condition, section should pass through selected member. Second condition, section should divide the entire structure into two separate parts. And few students may get doubt. Sir, okay, section should divide the entire structure into two separate parts. Is it equal parts, sir? Maybe, may not be. Okay, just section should divide entire structure into two separate parts. Right. Then after dividing entire structure into two separate parts, then either do analysis for left part of the structure or right part of the structure. For any one part of the structure, we have to analyze. If you choose left part or right part, you will get the same answer. Students, is these two conditions clear? How to cut the structure? So here I'll inject poison slowly, drop by drop. Okay, if I inject poison at a time now, you won't understand the concepts. Okay? Yes, namaste, good evening. Is these two conditions clear, everyone? Sir, I messaged in your WhatsApp number, no reply. So I can't see the WhatsApp messages now. I can see only your live chat. Okay, right. Okay, anyway, okay. So two conditions are clear, right? Now, for example, I want to do analysis for left part of the structure. In the left part, right part, you will get the same answer. Now, I'll draw the left part of the structure separately. Okay, just draw the left part of the structure separately. Okay, right. Students, we are doing analysis for left part of the structure now. Then only for left part cut members, only for left part cut members, initially assume tensile force. Okay, only for left part cut members, initially assume tensile force. Few students may get doubt, sir, why to assume tensile force, sir? I'll assume compressive force, sir. That is your wish. You can assume compressive force or tensile force, whatever it is. Finally, after finding the force in member CD, if we get positive value, then positive sign implies assumption is correct. If we get negative value now, then assumption is wrong, then it means it is not tension, it is compression. Okay, but I'll prefer always initially tensile force. In all the members, we'll initially assume tensile forces only. But students, I'm telling you, we have to assume tensile forces only in cut members, only for cut members. Okay, now these are the cut members, right? Now only for cut members, initially assume tensile force. Okay, right. Then here there is a support, right? And here horizontal reaction we got 0 and vertical reaction value we got W by 2. Now this is A. So this is D. So this is the free body diagram of left part of the structure. Okay, free body diagram of left part of the structure. Right. Students, this is the length L and this height also L na. Now can anyone tell what is this theta value? Okay, so your theta is 45 degrees. Yes or no? Okay, length L, height also L, then theta is nothing but 45 degrees. Okay, right. Now students, in which member we have to find the force? In member CD, right? Now we have three equilibrium equations. Okay, we have three equilibrium equations. What are the three equilibrium equations? Sigma H, sigma V and sigma M. Now using these three equilibrium equations, we have to find the force in member CD. Right. To save the time in examination, here I'll give one hint. For which member, which equilibrium equations are preferable? Students, if I ask you to find the force in horizontal member, okay, if I ask you to find the force in horizontal member, preferable equilibrium equations are sigma H equals to 0 and sigma M equals to 0. Okay, sigma H and sigma M equals to 0. No need to try with sigma V for horizontal member, waste of time in examination. Okay, next, if I ask you to find the force in vertical member, okay, if I ask you to find the force in vertical member, preferable equilibrium equations sigma V equals to 0 and sigma M equals to 0. No need to try with sigma H equals to 0, again waste of time for vertical members. Then if I ask you to find the force in diagonal member, that is inclined member, first prefer sigma H equals to 0. If it is not possible, next sigma V equals to 0. If it is not possible, then next try with sigma M equals to 0. And few students may get doubt, sir, if sigma m also not possible, then how, sir? If sigma m also not possible means this vertical cut is not possible. We have to cut the structure in another direction. Okay, you can cut in any direction, students. Horizontally cut to, vertically cut to, incline cut to, U cut to, V cut to, any shape. But two conditions must satisfy. What are the two conditions? Already explained. Okay, right. Right, students, now I want to find the force in member CD, right? Member CD, is it horizontal member, vertical member or inclined member? Member CD. Member CD is inclined member, right? For inclined member, preferable equilibrium equations, sigma H equals to 0, sigma V equals to 0 and sigma M equals to 0. Right? First, I'll try with sigma H equals to 0. Okay, first we'll try with sigma H equals to 0. Is it possible or not? Check it. Students, tell me, using one equilibrium equation, we can find only one unknown, right? Yes or no? Using one equilibrium equation, we can find only one unknown at a time. Here, using one horizontal equilibrium equation, then we can find only one horizontal unknown, right? Now tell me, students, in this free body diagram, how many horizontal cut members are present? How many horizontal cut members I am asking? Cut members, horizontal cut members. Now this is the horizontal cut member. This is also horizontal cut member 2. Then students, this is inclined cut member, right? If inclined cut members are present, that inclined cut member we have to treat as a horizontal cut member, vertical cut member both. Because this inclined cut member we have to resolve in horizontal direction and vertical direction. Na? It means inclined cut member will get horizontal unknown, vertical unknown both. Now tell me, how many horizontal cut members are there? 3. 1, 2, 3. Now tell me, using one horizontal equilibrium equation, can you find the 3 horizontal unknowns at a time? No, it is not possible. It means sigma H is not possible. Okay, right. Next, we'll try with sigma V equals to 0. Using one vertical equilibrium equation, we can find only one vertical unknown, right? Now tell me, in this free body diagram, how many vertical cut members are there? How many vertical cut members I am saying? Students, this is not vertical cut member. I am asking vertical cut members. Okay, I told inclined cut member consider as a horizontal cut member, vertical cut member both, na? Okay, so here how many vertical cut members? Only one vertical cut member. Now using one vertical equilibrium equation, can you find one vertical unknown at a time? Yes. Now sigma V is possible. Now using sigma V equals to 0, now we will get the force in member CD. Okay, right. Now sigma V equals to 0, nothing but downward forces equals to upward forces. All the downward forces equals to all the upward forces, nothing but balancing of vertical forces. Okay, balancing of vertical forces. Right. Now in this diagram, what are the downward forces? What are the downward forces in this free body diagram? Students, this arrow mark is downward na. Now tell me, what is the vertical component here? This vertical component. So this vertical component, force in member C, right? And vertical component, then this is sine theta. Okay, vertical component is sine theta, right? Now theta is nothing but 45 degrees. Okay, so here this force is downward. Force in member CD, sine theta, theta is nothing but 45 degrees equals to. Then what are the upward forces in this diagram? In this free body diagram, we have only one upward force, that is reaction W by 2. Okay, so W by 2. Now, from this equation, can you find the force in member CD? Find the force in member CD. Okay, then this is W by root 2. Okay, W by root 2. Okay, so here we got positive or negative. Here we got positive value, right? Then positive sign implies assumed direction is correct. So initially we assume tension force na. Yes, now we got positive. Yes, this is the tension only. Now this is the force in member CD is tension W by root 2. Clear this, everyone? Right. Yeah, I'll inject poison slowly. Okay. Ishwar, if I directly explain difficult, tough problems na, because who don't know the concepts, they will face the problems. Okay. First, let me explain the concepts, then you can solve any tough questions. Okay. Right. Right. Students, now second question, I want to find the force in member DE. Okay, I want to find the force in member DE. So to learn the subject, first you have to learn the concepts. Once you know the concept na, then you can solve any question. Okay, so this is the question, right? Now this is A, this is B, C, D, E. And this is F. Okay, so already we calculated vertical reaction, we got W by 2 and here W by 2. And horizontal reaction we got here 0. Now I want to find the force in member CD. Okay, I want to find the force in member CD. Right. Now tell me, students, how to cut the structure to find the force in member CD. Okay, I told to cut the structure, two conditions must satisfy. First condition, section should pass through selected member. Second condition, section should divide the entire structure into two separate parts. Right. Now students, for example, again I'll cut the structure vertically. You can do analysis for left part or right part. Better always do analysis which part has less forces. Because if the forces are less na, then calculation part is less, then you can save the time in examination. Okay, right. So there is a load in right part of the structure, so better do analysis for left part of the structure. Again, only for left part cut members, initially assume tensile force. Only for left part cut members, initially assume tensile forces. Okay, right. Now again, draw the free body diagram of left part of the structure. So this dotted portion is right part of the structure. So this is the free body diagram. So we got a vertical reaction W by 2 and a horizontal reaction is 0. Length L, length L. Okay, right. Then this is a C and this is D. So initially we assume tensile forces. Right. Students, tell me here which one is the selected member? CD, right? Now member CD, is it horizontal member, vertical member or inclined member? Member CD is horizontal member na. I told for horizontal members, preferable equilibrium equations are sigma H equals to 0 and sigma M equals to 0. Okay, so sigma H equals to 0 and sigma M equals to 0. Okay, right. Students, first we'll try with sigma H equals to 0. Okay, I told using one horizontal equilibrium equation, we can find only one horizontal unknown. Now tell me, in this free body diagram, how many horizontal cut members are present? 1, 2, and inclined cut member consider as a horizontal cut member and vertical cut member both na. Okay, it means 3 horizontal cut members. Now using one horizontal equilibrium equation, can you find the 3 horizontal unknowns at a time? So not possible. If only one horizontal unknown is there, yes, it is possible. Next, then sigma M. Now sigma M, is it possible or not? How to know? Students, for moment equilibrium equation, we have to follow wanted and unwanted member concept. Okay, for moment equilibrium equation. Sir, how to know which one is wanted and which one is unwanted member, sir? Students, here we want to find the force in which member? We have to find the force in member CD, right? Now member CD is wanted member. Okay, member CD is wanted member. Students, we have to do analysis only for cut members. Don't consider rest of members. Consider in the equation we have to consider only cut members. Okay, right. Now, this is a wanted member and what are the rest of cut members? This is a cut member, this is a cut member, right? Now, rest of cut members are unwanted members. Okay, rest of cut members are unwanted members. Now students, how to know sigma M, is it possible or not? Always remember, for moment equilibrium equation, I am stressing this point, for moment equilibrium equation, all the unwanted members should meet at single joint. All the unwanted members. At that point, wanted member should not meet. Okay, if you see here, students, line of action of this unwanted member meeting at joint F, line of action of this unwanted member meeting at joint F. Now tell me, all the unwanted members meeting at single joint or not? Yes. Now tell me, line of action of unwanted member, is it meeting at joint F? No. Then sigma M is possible. Okay, always for moment equilibrium equation, all the unwanted members should meet at single joint. At that joint, wanted member should not meet. If wanted member also meet at joint F na, then moment equilibrium equation also not possible. I'll show one example. Okay, yes, now here sigma M is possible. Right. Now use sigma M equals to 0. So anti-clockwise negative and clockwise moment is positive. So these are the sign conventions we'll follow, right, generally. Okay, right. Now tell me students, at which joint we have to consider moment. Okay, unwanted members, all the unwanted members meeting at joint F na, now we have to take moment about joint F. Okay, we have to take moment about joint F equals to 0. Okay, then we are doing analysis for left part now. Then students, consider only left part forces. Don't consider right part forces. Consider only left part of the structure forces. Okay, right. Now tell me, our target is joint F, right? Now tell me, this wanted member clockwise or anti-clockwise toward the joint F? Wanted member, yes, this is clockwise. Then force into what the perpendicular distance up to joint F from here to here. What the perpendicular distance? L. Then clockwise, force in member CD, perpendicular distance is L. Now this is a wanted member. Okay, then tell me students, these two unwanted members, will it develop moment at joint F? No, because line of action of these two unwanted members meeting at joint F only. Next, and here two reactions are there. Horizontal reaction is 0. Forget about horizontal reaction. Then what about vertical reaction? Is it 0? No. Then this vertical reaction develop clockwise movement or anti-clockwise movement? This develop clockwise movement. From here to here, what the perpendicular distance? L. Then this is plus W by 2 into L equals to 0. Then from this equation, what is the force in member CD, students? This is minus W by 2. So minus is present, assumption is wrong. Initially we assume tensile force now it is not tensile force, it is compressive force. Now force in member CD is W by 2, then this is compression. Why compression? Because here we got negative. So negative sign implies assumption is wrong. Clear, students? And remember, students, wanted unwanted member concept we have to use only for moment equilibrium equation. Navin Reddy. Sir, can I get your online classes, sir? Okay, I'll talk to you later, Navin Reddy. Ishwar, okay, in next class I'll try to explain ILD concepts, okay? Right. Okay, and few students may get doubt, okay? Sir, why are you cutting in vertical direction, sir? I'll cut the structure like this. Okay, I'll cut the structure like this. Just I'll remove this vertical cut. Right. Now check it. First condition, section is passing through selected member or not? Yes, selected member is CD na? Yes, section is passing through member CD. First condition is satisfied. Second condition, this section dividing entire structure into two separate parts. Yes, this is the left part and this is the right part. Yes, two separate parts. Then why can't we try this one, sir? Okay, we'll try this one now. Okay, then students, I'll draw the free, I want to do analysis left part of the structure. Then only for cut members, initially assume tensile force. Okay, initially assume tensile force only for cut members. Then I told we have to do analysis only for cut members. Now I'll draw the free body diagram separately. Okay, just I'll write it here. So this is the free body diagram of which joint? C. Okay, so here it is tensile force. Okay, then this is the joint D and this is the joint F and this is the joint A. Okay, this is the theta 45 degrees. Now we'll try. Why not this section? Okay, right. Students, I want to find the force in member CD, horizontal member, right? For horizontal member, preferable equilibrium equations, sigma h equals to 0 and sigma m equals to 0. First, we'll try with sigma h equals to 0. Now tell me, In this free body diagram, how many horizontal cut members are present? 1, 2. So more than one horizontal cut member is there now. If only one horizontal cut member is there, then sigma h is possible. But here more than one horizontal cut member, then sigma h is not possible. Again, we'll try with sigma m. So I told for moment equilibrium equation, we have to follow concept wanted and unwanted members. Okay, now this is wanted, right? Okay, this is wanted and the rest of two are unwanted members. Okay, rest of two are unwanted members. Now tell me students, for moment equilibrium equation, I told all the unwanted members should meet at single joint now. Right, now look at here. Line of action of this unwanted member meeting at joint C, and line of action of this unwanted member meeting at joint C. Now tell me, all the unwanted members meeting at single joint or not? That is at C. Possible? No, it is not possible. Reason is, here wanted member, line of action of wanted member also meeting at joint C. I told all the cut members do not meet at single joint. All the cut members. I told only unwanted members should meet at single joint. Okay, so here all the cut members line of action of this forces meeting at joint C, then sigma m also not possible. Then sigma h not possible, sigma m not possible. It means this cut is not possible. Okay, we have to try with another cut. That is vertical cut, already we tried. Students, for the same member, more than single sections also possible, even though you will get the same answer for few questions. Is it clear, everyone? Dinesh, can you cut horizontal also? Yes, you can try with horizontal. You can try with horizontal. Okay, Dinesh, I'll try horizontal. Right. So horizontally cut to Dinesh. Shall I do analysis for upper part or lower part? Dinesh, your wish. Upper part or lower part? Okay, any part you will get the same answer. For example, I'll do analysis for upper part, then only for cut members, upper part cut members, initially assume tensile force. Only for upper part cut members. Why only for upper part cut members? Because I am doing analysis only for upper part of the structure. If you want to do analysis for lower part of the structure, then only for lower part cut members initially assume tensile force. You can assume compressive force also, your wish. Final value if you get positive, then assumption is right. If you get negative, then assumption is wrong. We have to change the direction. Okay, right. Now tell me, Dinesh, you are saying upper. Okay, I consider upper only, Dinesh. Okay, right. So we have to find the force in member. Which member? Okay, in member CD, right? Now tell me, condition, is it satisfying? Dinesh, if I cut the structure horizontal, two conditions are satisfying. I told first condition, section should pass through selected member. Which one is the selected member? CD, right? Now tell me, this section, is it passing through member CD? No, right? Is it clear, Dinesh? Okay, so how to cut the structure? It depends upon two conditions. First condition, section should pass through selected member. Second condition, section should divide the entire structure into two separate parts. But here, section is not passing through selected member CD. Clear? Right. Now, next question. Then after this, I'll change the diagram. Right. So next question is, I want to find the force in member AF. I want to find the force in member AF. Okay. So already we calculated support reactions. Here we got W by 2. Here we got W by 2. And what is the horizontal reaction we got? It is 0. Now tell me students, I want to find the force in member AF. Then how to cut the structure? But while cutting the structure, you have to remember, you have to follow the two conditions. That's it. Tell me please, how to cut the structure? Okay. For example, I'll cut the structure like this. Incline cut to. Then I'll do analysis for left part of the structure. Then only for left part of the structure, only for cut members, initially assume tensile force, only for cut members. Just I'll draw the free body diagram of left part. But students, always no need to draw a free body diagram in examination, it is waste of time. Just for your clarity, I'm drawing free body diagrams here, that's it. Okay, so here it is W by 2 and horizontal reaction we got 0. Okay, then this is C and this is F. Okay, right. So we have to find the force in which member? AF, right? Horizontal member. For horizontal member, preferable equilibrium equations are sigma H equals to 0 and sigma M equals to 0. First we'll try with sigma H equals to 0. Tell me, in this free body diagram, how many horizontal cut members are present? How many horizontal cut members? How many horizontal cut members? Only one horizontal cut member is there na. If only one horizontal cut member is there, then sigma H is possible or not? Yes, it is possible. Then use sigma H equals to 0. That is, all the right forces equals to all the left forces. We are doing analysis only for left part of the structure. Then don't consider what are the forces in right part of the structure. We are balancing only left part of the structure. Okay, you can balance the portion of the structure or complete structure. Okay, right. Now tell me here, this arrow right side, right? It means this force is right side. Force in member AF is right side. Okay, force in member AF is right side, and this horizontal reaction also right side, but this is 0. Okay, then equals to, in this free body diagram, what are the left forces? No, left forces 0. Now what is the force in member AF? It is 0 only. Now few students may get doubt. Sir, force in member AF we got 0, then is it required to place the member AF, sir, in the structure? Yes, required for stability purpose. Okay, for stability purpose, practically we never remove the 0 force members from the structure for stability purpose. Okay, right. Now students, for the same diagram, I told for the same member sometimes more than one sections also possible. More than one sections also possible. Okay, so here I take an incline cut, right? I'll try with another cut for same question. Just I am removing this one. Right. So here I'll cut vertically. Check it, is it possible or not? Sometimes more than single sections also possible. Again, I want to do analysis for left part to save the time. Yes, only for left part cut members initially assume tensile force. Okay, right. Students, now we have to find the force in member. Which member? AF horizontal member only. For horizontal member, I told preferable equilibrium equation sigma h and sigma m. We are doing analysis for left part of the structure. Okay, right. Tell me sigma h equals to 0. First, we'll try with sigma h equals to 0. How many horizontal cut members are there? 1, 2, 3. So more than one horizontal cut member is there na. It means sigma h is not possible. Next, try with sigma m. I told for sigma m, which concept we have to follow? Wanted and unwanted member concept. Okay. Now tell me which one is the wanted member here. I want to find the force in member AF, right? Now member AF is wanted member. Okay, member AF is wanted member and remaining cut members are unwanted members, right? Now these are the remaining cut members are unwanted members. I told sigma m possible or not to know, all the unwanted members should meet at single joint. Now tell me, here two unwanted members are there, right? Now this line of action of these two unwanted members, look here, line of action of this unwanted member meeting at joint C, line of action of this unwanted member meeting at joint C. And tell me, line of action of this wanted member, is it meeting at joint C? No. Then sigma m is possible. Okay. At which joint we have to take moment? Line of action of unwanted members meeting at joint C na. Now taking moment about joint C. So anti-clockwise negative, clockwise positive. We are doing analysis only for left part of the structure na. Then consider only left part forces. Don't consider right part forces. Dinesh, there is no minimum number of members. Okay, in the cut, number of members are 2, 3, 4, 5, whatever it is. But just condition should satisfy. That's it. Okay, right. Now we are doing analysis for left part na. In the left part, target is which joint? C, right? Now tell me, this wanted member toward the joint C, clockwise or anti-clockwise? Toward the joint C, this wanted member, this is anti-clockwise, right? Then minus force in member AF. Okay, then what is the perpendicular distance from A to length L? Okay, then unwanted members will not develop moment because line of action of unwanted members meeting at C only. Next, in left part, two reactions are there and this reaction is 0. No need to consider horizontal reaction. And vertical reaction W by 2, right? Now tell me, line of action of vertical reaction. Line of action of vertical reaction, it is meeting at joint C only, na? It means this vertical reaction, will it develop moment about C? No. Then equals to 0. Now what is the force in member AF, students? It is 0 only. Now tell me. Okay. So for the same, we are getting same answer or not? Here 0, here 0. It means for the same member, sometimes more than single sections also possible. Even though you will get the same answer only. Clear, students? Right. Just I'll give one question. Right. Can anyone find the force in member AE? I need force in member AE. Just tell me how to cut the structure first. How to cut the structure? How to cut the structure? Okay, just I'll cut the structure like this. Okay, just only for cut members, initially assume tensile forces. Now these are the cut members, right? Assume tensile forces only for cut members. Okay, so I want to do analysis for upper part of the structure, because if I do analysis for lower part now, then you have to find the support reactions. It is waste of time in examination. If possible, using method of section, try to avoid finding support reaction if it is possible. If there is no possible, then we have to find the support reactions first. Okay, right. Now we have to find the force in member AE. Member AE is vertical member, right? For vertical member, preferable equilibrium equation sigma V and sigma M. First we'll try with sigma V. How many vertical cut members are there in upper part? 1, 2. So more than one vertical cut members not possible. The next sigma M, again wanted member and unwanted member, right? Now this is the wanted member, right? This is wanted member. Then how many unwanted members are there? 1, 2, 3. So here 3 unwanted members are there. Now tell me, all the unwanted members, is it meeting at single joint? All the unwanted members, check it, line of action of unwanted members, is it meeting at single joint or not? Right, look at here. Line of action of this unwanted member meeting at joint C, line of action of this unwanted member meeting at joint C, and line of action of this unwanted member also meeting at joint C. And line of action of this wanted member, is it meeting at joint C? No. Then sigma M is possible. Okay, then taking moment about joint, C equals to 0. So you are doing analysis for which part? Upper part of the structure. Then consider only upper part forces. Don't consider lower part forces. Now wanted member clockwise or anti-clockwise? This is anti-clockwise. Then force in member EA or AE. You can write EA or you can write it AE because both are same members. Okay. So this is anti-clockwise na, minus what the perpendicular distance up to C? It is 6 meter. Okay, then in upper part, this 5 clockwise or anti-clockwise towards C. This is anti-clockwise, minus 5 into what the perpendicular distance from here to here? It is 6. Okay, then there is a 10 clockwise or anti-clockwise toward the joint C. This is clockwise na, plus 10 into what the perpendicular distance from here to C? It is 3 meter. Then equals to 0. Okay, then what is the force in member EA, students? It is 0. Okay, so minus 30 plus 30, then you will get 0 only. Okay, if red is not visible, so line of action of all the unwanted members meeting at joint C only. Okay, right. So like this we have to solve more number of questions, then only you will know how to cut the structure. So how to cut the structure you will know by practicing number of questions. Okay, so but we have only 1 hour schedule, right? Okay, so I tried level my best. Okay, so I have to stop the lecture here. Okay, so next time I'll come with different concept. Okay, so students, I'll stay for 5 minutes. If you have doubts, you can ask me. Dinesh, how to find the support reactions? Then I have to spend that time. Okay, so in next video, I'll try to cover how to find the support reactions also. Okay, Dinesh, it is very easy only. In yesterday video, I told this is the conceptual subject. Each and every chapter has link. Okay, so why I chosen this topic na? It's as less continuity. Okay, so if I explain ILD chapter, okay, or moment distribution method or slope deflection method, it requires some concepts. Okay, so within less time I can't explain all the concepts now. Yes, it is used for AW also. These chapter concepts are useful for any competitive exam, not only for GATE and IS, for any competitive exams. Actually, these are the basis concepts. Thank you, Dinesh. Your classes are there on online. Navin, you won't get my free classes, complete classes. Okay. Actually, this is my first live class I'm giving my concepts. Navin. Till now in YouTube section, just I given preparation strategy, important concepts and weightage only. Okay, but till now I didn't explain any single concept in live session in YouTube. This is the way first I given first concept. Okay, Navin Reddy. So you won't get my classes free of cost. If you take admission in ACE Engineering Academy, then you can see my all classes, complete subject. Okay, students? Tomorrow is there sir class? No. Okay, only one schedule I got today. Okay. Yes, Ishwar. Right. So student session is given up to 8 o'clock only, na? 7 to 8. So have to end the session. Okay. So good night, students. Next time we'll meet with another concept.
My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal.